The mission of the Deng Lab is to develop predictive immunology blood tests. The concept is based on the overarching idea that the immune system cells and the whole immune system is governing as a systemic organ, linking all different organs and basically allowing to orchestrate what we call fitness and conditions that reduce fitness based on certain organ dysfunction syndromes, like if someone has a heart attack and the heart doesn't pump blood anymore, and then impairs also kidney function, liver function, brain function, gut function, muscle function, and all of these different organs in their reduced capacity of functioning have a communication with the innate and adaptive immune system cells, the white blood cells, that can be captured by doing the sampling of blood that we're doing. That allows to link the information in the immune system cell or the white blood cell to the clinical outcomes. That is not possible if you don't have that detailed access, but only general clinical prediction parameters. The first project that we completed in this context was the AllomapTM project. It allows to rule out heart transplant rejection without taking 4 little pieces out of the recipient's heart, putting them under the microscope and look at the presence or absence of white blood cells infiltrating that heart muscle tissue and potentially leading to destruction of that tissue. In contrast, the molecular blood test AllomapTM, we hypothesized that several hundred genes would be differentially activated in a situation of rejection versus a situation of no rejection or quiescence. And that concept worked. You just need the AllomapTM blood test, a molecular immunology blood test that became the first test that the US Food and Drug Administration cleared to rule out heart transplant rejection in heart transplant recipients without the need for invasive heart muscle biopsies. The second test, the heart failure survival prediction test, MyLeukoMAP, is targeting a much larger population than the heart transplant test. The advanced heart failure survival prediction test is probably in the United States alone potentially benefiting out of those 3 million persons who have heart failure with reduced ejection, those 300,000 with advanced heart failure, in the prediction of outcomes or 1-year survival after any of these interventions that are meaningful potentially for a heart failure patient. And that allows the person with the heart failure condition who needs to make a decision whether or not they will go for the recommended intervention to make a more informed decision. The test is currently still in the validation phase with a pivotal study that goes on nationally. The third project, the long COVID outcome prediction test development, is underway. We have not yet constructed an algorithm because we're still collecting the data. We expect that project in a situation where out of 150 million people in the United States, about 10% at least have what is now called long COVID, 80% of whom are likely fulfilling Americans with disability criteria because they can't get going, can't stand up, can't exercise. But there is no quantitative test to document this. This test hopefully helps these persons with long COVID to have an improved health outcome and have an improved economic situation with protection against the being laid off work or being disabled, and the psychological effects of feeling isolated, because since there is no test, there's often the idea you don't have a problem with your body, it's all in your head. So the philosophy of the lab to develop those tests based on what's possible after the Human Genome Project was completed is to improve health outcomes in a comprehensive way that combines the high-value healthcare goals of the better and best possible patient experience, the best being lowest morbidity mortality, and obviously associated with that, the best cost effectiveness. Beyond that, we had over the last almost 10 years embarked on a novel hypothesis that moves beyond one singular cross-sectional blood testing in order to predict outcomes, and is based on standardized exercise testing. We hypothesize that from an evolutionary perspective, exercise was not meant to be looking good and show off on the beach, but was meant to actually do your work, let's say hunting. And let's say hunting a lion, you needed to really embark on your physical strength, and there was a small chance that the lion was biting. So in addition to heart, muscle, lungs, the immune system in a way needed to be in standby mode from resting condition to maximum exercise condition, just in case something would happen and the microorganisms from the lion's tooth would come into your body and the blood coagulation needed to be rapidly initiated. Now, in 99 out of 100 situations, nothing would happen. So once peak exercise is done, it needs to cool down rapidly. So that's what we hypothesized could be called immune fitness. All these 4 projects, the heart transplant rejection test, the heart failure survival prediction test, the long COVID prediction test, and the immune fitness prediction test, are embedded in a meta-level project that we call Science in the Making, a collaboration between our lab in the School of Medicine and Professor Federica Raia's lab in the School of Education that does practice research in the clinical setting, where we actually published the 2 books, the Relational Medicine book in 2014 and the Uncertainty book in 2023, now to study by video and audio recordings and after IRB consent of all participants to how we develop molecular tests. This is obviously a, let's say, vision that is having a very long-term perspective and has its ultimate motivation in improving patient care, best possible morbidity mortality, and best possible cost effectiveness. The future of the Deng Lab, and that is in 5-year plans, will be implementation of the heart failure survival prediction test clinically, will be implementation of the long COVID outcome prediction test, and proof of concept and hopefully implementation of the immune fitness test as a preventative medicine test. And that is the future where I personally feel that the work that I'm doing, and I'm seeing this in the next 2 5-year plans, as something that is going to unfold at the same time with generational transitions that allows the young generation to really get involved in original publications, in original grant funding, and basically take it to the next 2 to 10 5-year plans.